Okay people, so welcome to some revision for your 1.1 Extreme Natural Event Standard. Today we're going to talk about the processes that create a volcanic eruption below the Earth. Now most of the stuff I'm going to talk about is going to be general, but remember you need to name a specific volcanic eruption like Mount Ruapehu or Nevado del Ruiz in your answer to score. Really important that you remember to do that. So, we're going to start to talk about plate tectonics first, which is the movement of plates on the Earth's surface. So we already know that the Earth's crust is broken up into sections, which we call plates. There are about 12 major plates on the Earth's surface. There are two main types of plates that you'll be able to see. There is the continental, which has mostly countries or land on it. And it is thicker, but it is not as heavy as the oceanic plate, which has mostly ocean on it, obviously, and it is thinner, but it's much heavier and denser than the continental. Okay, so the Earth's crust and plates sit on top of a layer or float on top of a semi-liquid layer called the mantle. The mantle is made of semi-liquid rock, and this is important because it means that it can move. It is heated by the Earth's core, which is the hottest part of the Earth, and as it is heated down the bottom by the core, it causes the mantle or some of the rock in the mantle to rise up, and as it gets further away and closer to the crust and further away from the heat, it'll start to fall again. And this circular movement that you can see on the diagram, these are called convection currents, and these are really important because these things help to move the Earth's plates at a rate about 1 to 15 centimeters a year, depending on how hot the core and the mantle is in particular parts of the Earth's surface. So these convection currents mean that all plates can move independently of one another, and they can cause plates to meet together or to spread apart. When you get a continental and an oceanic plate moving together, this is when another process called subduction will occur. What happens here is because the oceanic plate is much heavier, it is forced below or subducted below the continental plate, which is much lighter. Okay, those convection currents are moving the plates, making the oceanic plate move down under the continental plate into the mantle. So when an oceanic plate like the Pacific plate in New Zealand and the Australian plate meet, you get subduction occurring. When one is forced below the other, you get a lot of friction occurring, like if you were to rub your hands together really fast, that causes a lot of friction, which causes a lot of heat. So as it's forced down, this causes the subducting plate, the oceanic plate, to melt, and this forms magma, which collects underneath the Earth's surface in areas called magma chambers. Mount Ruapehu's magma chamber is about 100 kilometers below the Earth's surface. So once you're getting this magma being formed, you get lots of gases like carbon dioxide and sulfur dioxide building up, which builds up the pressure that's under the Earth's surface in these magma chambers. Eventually, this magma, because it's under so much pressure, will look for a way to get out, and so it makes its way up to the Earth's surface through weak spots or cracks called fissures in the Earth's crust. This is where the processes below the Earth finish, so eventually the magma will make its way up to the Earth's surface. Then eventually you'll get a volcanic eruption, and this is where the processes that occur on the Earth, like volcanism, will start. Okay, so I hope this has been helpful, and study away.